Bismillah Rahman Rahim. Welcome to my channel, Learn Math with Syed Ali. Continuing our topic, EQAO Assessment Mathematics, grade 9 and 10. So we learned in the previous video that every positive number has two square roots, one negative of the other. For example, square root of 100 is 10 or minus 10, because when we multiply 10 with the positive integers, then plus 10 and plus 10 makes it 100, and minus 10 times minus 10 makes it 102, because negative times negative is positive. So that means every positive number has two square roots, one negative of the other. Second thing we will continue here in this video is that if expression is written as under root a over b, for every a is greater than or equals to 0, right, and b must be greater than 0, then we can rewrite square root on each numerator and denominator. So instead of writing the whole thing in square root, I can split that square root to a numerator and denominator separately. So hope you understand this, and we will do some practice for this quality of numbers, right? So if the numbers are like a is greater than 0 or equals to 0, or b must be greater than 0, then the square roots on the fraction can be separated on numerator and denominator. For example, 361 divided by 1024, and whole thing is under the root. So by this definition, I can rewrite it as separate 361 divided by 1024. And I requested all of my students that please go through all the square roots so that you can quickly manage the number. What is the square root of 361? So you have to guess and check, and then you will realize that it is 19, because 9 9s are 81. That brings you 1 here, right? And 20 times 20 is 400. So it would be less than 400. So you try 19, because 9 times 9 is 81, and you have to have 1 in the unit place or ones place. 1024 square root will be 32, right? So this is your answer. So in this exercise, we will be repeating all of such questions where the square root is on the whole fraction, and then we will separating them, the square root on numerator and denominator separately, and then do the square root of each positive numbers. So 36, square root of 36 is 6, right? And 961 is again 31, because if you do 30 times 30 is 900, so it should be more than 30, right? So it is 31. So next question is 289 divided by 625. So by the rule which we defined above, is we can have the square root on denominator and numerator. This is numerator, this is denominator separately, and then we see what is the square root of 289, and you will realize that it is 17, right? 7 7 is 49, so you will be having 289. 625, you remember that it is 25, so 17 over 25 is your answer. Then next question is just for practice, right? So you just go through it, and any question, any of these like questions can come in EQAO assessment exam. So 289, next is 169 over 784. So I will split it onto the numerator and denominator. So 169 square root is 13, and 784 square root is 28. So 13 over 28 is your answer. So we will try one more here. We have some space. 169. Okay, so if it is in decimal, square root 0.0081. So we have to remove the decimal first, and then we have to see what the numbers are in numerator and denominator. So we can say how to remove the decimal. we learn one more time here a little background of it, so that we know how to remove the decimal. So instead of decimal, we bring 1 and count the digits ahead of the decimal. 1, 2, 3, 4. So 4 digits, that means 40. 1, 2, 3, 4, 0. And if you do this, then this is all gone. So now your fraction is reduced to under root 81 divided by under root 10,000, right? It's 10,000, right? So under root 81 is equals to 9, and 10,000 square root is 100. So 9 over 100 is your answer. So for all decimal questions, you have to remove the decimal, make it into a proper fraction, and then you can take the square root of numerator and take the square root of denominator separately. Let's try a few more. So let's see why this pen is not working here. So under root, let me take this pen. So under root 0.0529. So what the procedure is, we have to remove the decimals. 0.0529. What we do is place 1 instead of decimal. So I put in the denominator and then count the digits. 1, 2, 3, 4. So 4 zeros. 1, 2, 3, 4. Right? So in this way, this is all gone. Now my equation reduced to square root of 529 divided by square root of 10,000. Right? And the square root of 529 is 23, right? The square root of 529 is 23 divided by 100, right? So this is how you can proceed. Next example is under root let's say another example is 2.25, right? So if this is your question, so you have to replace the decimal first. By the method, we learned that in place of decimal, you put 1 underneath in the denominator and then count the digits, 2 digits after decimal, so 2 zeros. Now my question, this is gone now. So my question reduced to 225 over 100. So 225 square root is 15 and 100 is 10. And I can simplify it. 5 3 the 15, 5 to the 10. So my answer is reduced fraction 3 by 2. Right? So this is how we did this one. We can take another example, maybe 729, or I can write in decimal first and then I can reduce the decimal to the fraction. So 0.0729. So which means I have to change the decimal, replace the decimal 0.0729. And what is the procedure? We put 1 in place of decimal in the denominator and count the digits 1, 2, 3, 4. So 4 zeros. And then this all gone, right? So now my question reduced to under root 729 divided by under root 10,000. So under root 729 is 27, very good. And 10,000 is again 100. So 27 divided by 100 is my answer. So in this way, you can attempt many of those questions if they are written in a fraction form and the whole decimal and whole square root, then whole square root can be separated or broken as an individual square root of the numerator and denominator, what we learned today. And then we can take the square root of the numerator and the square root of the denominator separately. So this is how, this is lecture number 2 for EQAO assessment mathematics for grade 9 and 10. Hope you like the video. If you like it, subscribe to my channel, Learn Math with Syed Ali. Share it, thumbs up. Thank you for watching.